Okay, so let's continue in section 4.2. And in terms of terminology, I forgot to mention that when a function f goes from a to b is onto b, we also call this a surjection. So another word for onto is surjection. So you may see in the homework or see somewhere in the book, prove that something is a surjection. That just means prove it's onto the codomain. Okay. We're going to look at one more example of proving something is onto. So here, and this is also given in your books, but there are other examples, so I didn't want to do them all, but you need to read this section thoroughly. There are a lot of different things in here that I'm not going to cover. I'm just basically covering the main definitions that's in this chapter, but to fully understand onto and one-to-one, you really need to read this chapter thoroughly, okay? All right, so here we need to prove, and I like this example because it's something a little different than what we're used to. So we need to prove that now M is defined, the domain is Z cross Z, so that's the integers, and it maps to Z, okay? And so it's given by, since our domain is an ordered pair, right, because it's Z cross Z, then our elements in our domain are ordered pairs, but in the range is just an integer. So in our codomain, I should say, then that equals xy. Okay. Once we prove something is a surjection, then we can just say range, right? Because we're saying that the range equals the codomain. Okay. So for this proof, to prove it's a surjection, we start with our side work. Okay. And in our side work, I like to just put what I'm trying to prove. So in our side work, for all y belonging to z, in this case, there exists an xy, the order pair xy belonging to z cross z, such that m of xy equals y. Okay, so again, that's just by the definition of a surjection. That's what we're trying to prove. Okay, so m of xy, well, we know that equals to xy, right? So that's what that is. So we set m of xy equal to y, and then we solve. So we divide by 1 on both sides, x equals 1. All right, so this is the instance where it's just 1. It's not dependent upon y. Remember I said that there's always exceptions to the rule, so that's just an exception. Okay, so now looking at the proof. Okay, and so we look back at, in our side work, this is what we're trying to prove, this right here. For all y belonging to z, so therefore our first line will be let y belong to z, right? Then our second line, let xy belong to z cross z, such that xy is going to equal to 1y, right? Because x is equal to 1, okay? So m of xy equals m of 1y, and by what we were given, that equals 1 times y, which equals y. Isn't that beautiful? And we're done. So therefore, m is a surjection. Okay. Now in your notes, so now I want you to stop, and in your notes, I want you to write down theorems. All right, because I'm not going to waste time here to write them down when you can just do that. 4.3.1 and 4.3.2. So go ahead and stop the video and write them in your notes. Okay, so now we have a new definition. So we talked about onto, we did a couple examples. Now I want to look at, there are only 2 main definitions in here. So the next main one is our one-to-one function. And so a function f from a to b is 1-to-1 And this, or it's called an injection. So onto is a surjection. One-to-one is an injection. Okay. And so this means if f of x equals f of y, then x equals y. And for notation's sake, we usually use 1-1 to represent one-to-one. Okay. And if you think about what one-to-one is saying, is that a number has to go. So remember, in terms of, this is sort of an aside. If we had, let's say, wait, I'm going to do it on a different page. Okay, so I just want you to understand what what both definitions are saying, okay? And this might be helpful in your homework. So let's say we have, this is our, let's A represent our domain and B represent our codomain, right? Okay, and I'm going to add, I don't know what I just did. Okay, I'm going to add 3 and 4. Okay. Here. Okay. And say we want to talk about f being onto. Okay. So onto function means that every element in our codomain gets hit by something in our domain. So an example of an onto function would be f of 1 equals 4, f of 2 equals 5, f of 3 equals 5, and f of 4 equals 6, right? Okay. So as we can see, this is an example of onto because every element in our domain gets hit by element in our range. Let me rephrase. Every element in our codomain comes from an element in our domain. And I hope I'm not confusing you. Okay. But so that's why you can see in the instance when a function is onto that the codomain actually equals the range. Okay, this is for an onto function. Now for one-to-one, this is saying if f of x equals f of y, then x had to equal y. Okay. Another way to say that is if you do the contrapositive of that, if x doesn't equal y, then f of x doesn't equal f of y. And so here, this function, so we can actually look back at this function. This function would not be one-to-one because we can see that f of 2 equals 5 and f of 3. So this is a good example. So not one-to-one since f of 2 equals f of 3, but 2 doesn't equal 3. Okay. And in fact, we'll talk further about this in the next chapter and in the upcoming sections. But in fact, it's not possible to make a one-to-one function with the elements in A mapping to the elements of B. And I hope you can see that, and I hope you can see why, and we'll talk about that at another date and time. Okay, so let's get back to our one-to-one function. Okay, so we're going to show that f going from R to R defined by f of x equals 3x plus 1 is an injection, or it's one-to-one. All right, so here to prove that, again, we sort of reiterate what's given. Let f be a function going from R to R, be defined. Okay, and yes, you do need to put this in your proof because you want to make sure you have a complete proof. And so suppose your if, that's why I love if and then statements. Suppose f of x equals f of y. Okay, well that means, okay, that 3x plus 5 equals 3y plus 5, and then you continue solving until hopefully, if you're proving an injection, you get x equals y. And so we subtract 5. So 3x equals 3y. Thus, x equals y. Excuse me. And I don't want to start on a new page. So therefore, F is 1 to 1. Okay. And we are done with, so that's 1 to 1. Now what I want you to do is write down theorems 4.33, 4.34, and 4.35 in your notes, and actually make sure you understand them. I think some of the proofs are left as exercises that I think I might have gave you one of them to prove. But we are done with section 4.3. I'm done, I should say, with section 4.3. You all still need to make sure you go through and read the entire section. I covered the main definitions, but you need to make sure you understand them. And they really give you a lot of examples in this section. So make sure you really pay attention to them and see if you can prove those theorems and proofs that's in there and understand. Okay.